Dan from Fanatik.
Oh, hey there, Wade.
Welcome to Rocky Mountain, North Vancouver.
10 mil extra, so you can't even tell them.
Well, you've been watching us break parts, test parts out, see what it takes to destroy things, but it turns out there's actually a ton that goes into designing mountain bikes and the products that support them. So I found myself in beautiful Vancouver, British Columbia on this surprisingly sunny day at Rocky Mountain Cycles to talk with some experts and see what it actually takes to bring a mountain bike to fruition. Let's see what it's all about.
Sometimes I don't want to destroy the bikes, but they must be destroyed.
Yeah, I'm excited to be
you?
here. This has been, what, like 25 years for you?
For Rocky Mountain?
Yeah.
I think I started 94, 95 season, racing downhill.
Let me guess, BMX background.
BMX background for
Who'da
9
thunk?
years racing. Kind of got sick of BMX and mountain biking was just happening, and got a Fisher Hukuiku, my first mountain bike.
That was actually my first mountain
the
bike
green one?
too. No, I had a blue one. I'm a little bit younger than you, but I had Hukuiku, a nice blue Hukuiku. Yeah,
Let's go inside and I'll tour you around,
Let's
buddy.
check it out.
Yeah.
The Hall of History,
This
it
is
seems.
the welcome hallway here, a bit of history. This would have been like mid-90s. Actually, I actually rode one of these. I probably filmed a couple segments back in the Digger North Shore Extreme videos on these bikes. A lot of skinnies, blowing a lot of these shocks.
Some flat drops.
This is an old bike of Jeff Gullovich's, early 2000s, mid 2000s.
I bet this would still rip today.
Well, it's called the Tug Link, and a lot of bikes still use that. Like if you look at some different designs, I'm not going to mention which companies
Fair enough.
have used this design, but
I can think of one off the top of my
it's
head.
essentially a single pivot,
Yeah.
but it's a linkage-driven shock and super supple. We build bikes to ride on the shore. Our trails are super technical.
They are.
You know, and I like to say, you know, I'm a sales guy now.
Yeah.
We'll get into that later, but I've kind of morphed into a bit of a sales rep.
Well, you're a good spokesperson. for
Yeah,
it.
I'm a good, I mean, I love Rocky. I love the brand. If you come from California, Colorado, you're like, maybe these bikes are too active. But it's like our trails have 3 smooth spots, and those trails might have 3 technical spots. That's what I say to people.
Tech the whole way through.
Dude, check this thing out. This bike is super active. Like it popped really well. This is travel, so
Oh, yeah.
if you undid this, it would go slacker.
That's rad.
Yeah, so it would drop the BB a little bit and slacken your head tube.
Man.
I think this was kind of like early 2000s.
Yeah.
Travel design. This is an early edition of a 4-bar. We did this in a DH one too, the Element DH. I think it had all of like 5 inches of travel with the
totally.
Judy,
And
the
you're
Judy DH.
Rocking the V-brakes. and that
Down
thing
a low,
flexing.
right? You know, I'm in the big ring. And then this was a classic bike, a Prestige, chromoly, lightweight. Guys like Bruce Spicer, Allison Sador.
Yeah.
You know these names?
I don't know.
You don't know, yeah. You better get on the internet.
Yeah.
We got our mannequins here. These guys have been with us for a long time.
Dressed to the nines.
You know, Rocky, like I said, we don't rest on our laurels. We're kind of like, you know, we were the first company to have a freeride team. Back in the day, I don't know if you remember this, but Cannondale had a patent on the word freeride.
I don't know that.
And they actually had a lawsuit, and we came out with flow riders, and it was dropped.
Yeah.
But they actually started a
how
lawsuit
you-
against us.
you get around that.
We own the word freeride. So, anyways, it was soon dropped. But dude, look at this thing. This is an RM9.
Look at that swing arm.
Yeah,
Your bike.
I had one of these setting it,
That looks badass.
usually paired with a Monster T.
I think I like the flames better though.
For the big sends, yeah, I think that, the flames is good. This is a new Element. This is kind of, I think it's one of our staff rides, but you just look at this bike and it just looks fast.
It does.
You know, with the other ones, like, and then you look at this thing, it looks circus. Is that actually your bike? Yep. This is a pipeline. Another unified, like the other unified bike we're showing over
Oh,
there.
look at
Yep.
these to like stiffen up the brake. What?
Can't
You
get
can just
it.
pop it up
Yeah, you
there.
pop it up and down. Yeah,
Sweet.
full slack. They're steep, right? You can imagine as that goes up, it would push the front end forward, so it would get steeper, more cross country. And it's in the long travel mode right now.
That's
long travel.
I do love the hydraulic rim brakes.
One of my best segments that I'm pretty proud of, I think it was, I was in Turkey riding this bike, the Pipeline, for Crank 3. If you ever want to go through the archive,
Yeah.
VHS video, Crank 3.
Yeah.
I got rad on one of these,
All right.
like pretty rad. Way more rad than I should have gotten. Oh yeah.
I'm seeing some awards maybe.
Yeah, come in. Dude, look at this. Okay, you know that I won the first Red Bull Rampage? You
Yeah.
Know, you know what the Red Bull Rampage is? You know
Yeah,
about
I've heard of
that
it.
little event that goes
I'm
on in
familiar.
Utah? I won the first one.
It's like formation.
Yeah, it's like formation, exactly. It's the early formation.
Yeah.
Red Bull Rampage 2001, first place.
Hell yeah.
This was my
This
trophy.
is it.
This is my trophy. This is what I got.
That's sick.
Pretty high tech for back in 2001. And then various trophies from, like the Enduro World Series first place team, the rah shelf, eh? Not bad.
Cool. So you basically served as somewhat of like product tester for Rocky Mountain. You're like
I've been a product tester for a long time, yeah.
You're putting these bikes through their paces.
Yeah. I do some bigger picture feedback, but I'm more of I just like to send it. I'm a bit more like, it's good. Like, how much air pressure is that? Like, I've never used a tire gauge.
Yeah, just
I wouldn't even know what I run
check.
for pressure. I mean, I kind of know, but I've never tested. I'm like, that's good enough.
Know what it feels
like.
If I
get a bit of deflection, no, not enough air. Yeah. Our head design guy, kind of like R&D, his name's Lyle.
Sometimes I don't want to destroy the bikes, but they must be destroyed.
Yeah. Yeah.
And we should go talk to Lyle. He can,
let's do it.
Give you a bit more of an insight. Let's go track him down. Lyle!
Was that enough? Like, he just yells Lyle.
That's good, eh? Yeah. Lyle!
Hey, cool. How's it going? Good. We're basically done.
I love a maple Boston Green.
Backwards now.
I know. You guys ever hear of Tim Horton?
Oh yeah, we've met.
They're not bad, eh? I mean, they're not the best, but they're consistently good.
They get the job done.
They get the job done. Yeah. It's like, it's like going to McDonald's.
Yeah, my name's Lyle. I create bicycle snuff films.
I started in the last one.
Got some glaze on your mustache there.
Sorry, I'm deodorant.
When you prettied yourself up again.
Last time Wade was here, he pulled on my beard because it was too long.
And now it's
I was telling you that's what my wife does to me. She's like, what is that thing? It's like, what is that? The cool thing about Rocky is that we're at the shore, like gnarly trails. I mean, it's like this is the birthplace of skinny trails, right? Tech, yeah. We break a lot of bikes. I mean, bikes break. It's just the way it is, right? Because repetition, everything cracks and stuff, right? So, you asked me, did you break a lot of bikes? Like, yeah. I mean, I think, people say I broke the bike. I'm like, good. You're like riding hard. Like, you should break the bike. You know what I mean? And I know Lyle, who, what's your technical title? I don't even know.
I'm R&D coordinator.
The R&D coordinator here.
Yeah. I've broken a couple as well.
You break a couple of bikes as well, yeah. So that's what happens on the shore. It's hard on equipment. You get really drunk, you forget who you are. Like, Wade Simmons.
That's fine.
I got a mic.
Here we are in Rocky Mountain's Vancouver facility, one of two. The headquarters is in St. George, not Utah.
Yeah, St. George, Quebec.
Quebec,
Right, yeah.
Cool. And Lyle, what's your role here at Rocky Mountain?
Howdy. I am the R&D coordinator here. So this is sort of our R&D workspace. Basically, all the testing we do here parallels what we do in Asia. There's a whole 12 to 18 months of background work that goes into every frame at the very start of the process. We'll do a couple iterations of the kinematic, looking at it on paper first, and then we can pen the actual mule. Weld up a bike that's going to represent, what we want out of the final product kinematically. And so then we get to start test riding a platform and just seeing, how it benchmarks against a competitor bike, how it benchmarks against its predecessor internally. We're all bike nerds, we all ride. And so, when we get on a bike, we're hypercritical of how it feels. This is going to be the rear end on one of our new mules. I can't show you the rest of it. CNC'd yokes. We do a one-to-one drawing on the plotter just so that we can lay out the tubes and get the miters correct and just verify that our in-house, like these are incredibly crude tubes bent with a press, but it works. We have to think about the direction of the welds. This gets welded first because that will shrink in that direction. And then for the actual yoke at the front, well, we want the forces in a different direction and we want it to shrink as little as possible. So we do kind of a slash cut here and it can shrink in that direction during the weld. That phase of mule riding can sometimes lead into changes and we'll go, okay, well that was nice, but that's actually not what we want out of this platform. We want something poppier or we want something faster or smashier, When we're first defining bikes, we know what travel we want, we know how we want it to ride. In the case of the market right now, mullet's huge, idler bikes are huge. So this is one of our test mules. This is super high pivot, idler driven, low shock, all the cool things. This was mullet compatible. We made different chips so that it could be a mullet as well. And this thing is a sled. Ultimately, it's not what we want. There's a place for it, and these things are great on a racetrack. We have to try this sort of thing. We do ride competitors' bikes, but then we also build our own competitor bikes. This one looks a bit more like a Specialized, right? So here we're co-rotating with a yoke. There. Yeah, different movable shock mounts, so we could change the rate on this one. Just to try it, just to see if we can improve on it. Ultimately, we often end up sticking with what we know because we like it.
One thing that I'm very curious about, give us a rundown of what sort of things you're testing with these machines and how you go about doing it.
Well after the bikes are designed and mules are made here, we'll be getting factory samples. And that's what these machines are really for, is for testing factory sample bikes and ensuring that we see the same results that they see overseas. So this one is a standardized piece of equipment you'd find in any bicycle factory.
So the head tube is there. This is as if this were the fork, essentially.
Yeah, this is your big beefy fork. And it's basically, slamming the bike into a curb and then like landing a jump. Because when you land a jump and if your suspension fork did not compress, all that force would push the axle forward. So it basically pushes and pulls here, and it flexes the head tube zone of the bike.
And then so we have the rear axle is affixed
and the rear axle
there.
is fixed in place there, if you're going down a rocky slab and then under a compression that also has bumps in it, those kinds of forces will actually walk your frame back and forth and your wheelbase will change.
Cool.
The computer basically knows how much force is going into it, and if it starts to drift during the test, it'll trip itself and give you a warning because, hey, maybe your frame is cracking. And the goal is obviously to have frames not crack here. The EN standard is to do 50,000 cycles of this test. We run it 50,000 and then we go through the entirety of the rest of the test. And then sometimes we just put them back on here and run them till failure. And usually they go like 4 or 5 times the EN standard.
Cool.
So the small frames are some of the stiffest, but with the same length fork on them, they're imparting greater loads into the frame than the XL, which can maybe absorb more energy
throughout a much larger frame.
Tube set. I can talk about this machine here. This is our Chunyan pull tester, and it's used for ultimate failure testing. This is a small Slayer alloy. It has gone through all of our EN testing. So this one's actually done 230 on the horizontal machine and has not yet broken.
230 cycles?
230,000 cycles, which is almost 5 times the test standard.
Gotcha.
So this bike has already lived a life of abuse, so I don't feel too bad about ending it. And it's hard. Like sometimes I don't want to destroy the bikes, but they must be destroyed. It's going to be in this zone that it fails. It might be a bang, it might be a slow tear. The aluminum frames are not as spectacular as carbon. You start to hear plies separate and it starts snapping and popping, and then it becomes a chain of snapping and popping until it goes. Whereas the alloy is more consistent in its deformation, and we see it holding strength and holding until finally it deforms. And that's what we're really looking for, because that gives a rider some time, a lot of time, because they can ignore that for a long time. So I'll just count it out every 1,000 newtons. So that's 1,000 newtons force, 2,000 newtons, and that's just over an inch deflection now. That's 3,000. We're just approaching 2 inches of wheelbase growth. So we want to see this one around 4,000 and see the force curve is starting to level off. So we're incurring damage onto the frame right now. So we're just over 4,000 newtons and we're over 3 inches elongation.
You can start to see the crack forming behind the brace.
Yeah, looks like the top tube should go on this. Basically holding around 4,400 newtons, and it's now at 100 millimeters, so just around 4 inches of elongation. So this is great. This will survive anything anyone can throw at it. So what's happening now is it's yielded, and we'll see how it opens up. But basically, it's at 5 inches deflection, and it's completely yielding at around 4,000. So that's great. That's the kind of failure we're looking for, where the bike is still in one piece. That is a situation no one should encounter on their trail bike. So there you can see the down tube, and be careful because it is still storing 3,000 newtons of energy right now. So if we were to tap it with a hammer right now, that would be very bad. but you can see the down tube has totally wrinkled on the top at the shock brace, and the top tube has started, opening right up. One of our test riders can hit, 60, 70 foot gaps. And in doing so, he was able to dislodge the lower headset cup in our maiden frame. And that one was yielding, I think, around 6,000 newtons that was a carbon DH bike. We've actually exceeded that on most of our modern platforms now. So this is our pedal tester, and this one tries to pedal a bike to death. So the standard test for this is 100,000 cycles, which is twice the duration of those other two tests. It's basically like standing up and hammering on your cranks repeatedly, and you can simulate a couple years wear in just a few days on this machine. This is a pretty burly bike, so it's actually not moving as much as some of the frames. If we put an altitude or an element on here, then it'll move a whole lot more.
And will you see frames break from this machine?
Hopefully not.
Yeah.
Typically, if you do see a frame break, and I will say that hardtails can be more susceptible to it because they don't have any, they have a structure that doesn't allow as much twist as a full suspension bike.
Yeah.
Because you sort of get some flex at the pivots on a full suspension bike with a yoke. You will sometimes see bicycles fail at the chainstay weld.
Cool.
So one of the most stressed regions in this test is, in this area around the chainstay. So the inner skin here sees a lot of load. So this weld is critical to get right.
Gotcha.
So recently, in bringing this bike to production, we did discover a small crack that appeared on the shock plate. Basically, it was happening only during testing. We never saw any on any of the riding samples. But all we had to do was reduce this counterbore here on the forging and get a little bit more material thickness under the bolt head, and everything was fine. So it was just it was a pretty small thing that was overlooked, and then thankfully the machine caught it.
Sweet.
So
So this is how that machine caught that failure point of that thin little crack, because all that force is just getting partially routed up into here, and they found that it was just too thin. Actually, it was on the opposing side, but they just made that piece slightly thicker.
The worst thing that can happen to a bike is head tube separation.
Yeah.
Right. And so that's one thing we're always looking for. So that's why we're pulling frames apart to see how they go, to see how much force they can withstand before the head tube comes off, because that's critical.
Yeah.
For safety.
Yeah.
The other, the common failures we'll see are often, their seat stay failures. People will damage their bikes. Mountain bikes can get ragdolled down a hill, and then people will get right back on them and keep riding.
Yep.
This is just a small amount of warehouse space behind me. We've got supplies and tubes to build test mules. There are a few we've got to deal with. They're potentially soon to be recycling, or presumed soon to be museum pieces. We haven't decided yet. These are all test mules on the way to our current altitude power play platform. So we went through 3 different mules. We started with we went as big as a Slayer travel and tried that out. We did one with a pinion gearbox and to try that out. Yeah, that was this frame here. It was pretty adjustable. This one could take a pinion gearbox or a bottom bracket as well as our Dynami 3 motor.
Wow.
So it was a pretty complicated mess. It didn't really work out. So we have a Haas VF3, which is an older machine. We had to add a network card to it because this thing used to take floppy disks.
Yep.
After a frame is welded together, we give it a little bit of an alignment, and then we will chase the bearing bores and make sure the pivots are in the correct position.
How do you give it an alignment? What does that mean?
That's a lot of fun. While the frame is still soft after welding, you have a window of time in where you can adjust it. And as I mentioned, when you weld aluminum together, the material contracts and it moves, and you develop a process so that the frame is mostly perfect, but you can still tell once you put it on this table here, which is a standard bicycle alignment table. This one will clamp the BB here, and we have a number of levers. Seat post goes in here, and head tube goes in here. So it's the frame faces that way, non-drive side up, and you can adjust small components of this of the frame while it's on this table.
Now, this looks like a medieval torture device, and you said it's a standard.
It is, yeah.
tool.
Yeah. So this is, it's off the shelf, like Sh's tongue.
Oh, so we don't have one of these at our bike shop, but these are the factories, all the factories.
Yeah,
that are
you'll see this
assembling
in a bicycle frame factory. Yeah, a perfect bicycle frame is on plane, with your body, and has zero twist, and the geometry is what you want.
Okay.
So, once we achieve that, then we can take the soft frames and we throw them in our heat treating oven. And so then the frames will spend a day in the heat treating oven, and it's got a special process for 7005 aluminum. And at the end of that, then they're finally ready to ride.
I've seen people commenting about how in the bike industry, like QC and like these things are not that strict. Can you speak to that at all?
With contract manufacturing, you get what you put in.
Yeah.
And if you're attentive and you're in contact with your engineering counterparts, you can produce a great product that has high tolerance. Cool. You have to be detail oriented and have a strict process, a quality agreement, and all that has to be upfront at the time of the contracts between the factory and yourself. And it's hard to make a great product as a single bike and have it mass manufactured. It is hard to have an entire lineup of great bikes and have them mass manufactured. And it's tough in the bike industry, and I feel for the startups that have only one or two frames under their belts. It's harder to negotiate the manufacturing even.
But
so,
it is possible.
It is possible, yeah, and we're striving for that because a well-made frame lasts a person a long time. The bearings last longer. Everything lasts longer when it's within tolerance. If a frame is out of alignment, it will eat through pivots, it will eat through bearings, and the user might not have as good of an experience with it.
Yeah, Lyle, thanks so much for your time. Pleasure meeting you.
Yeah, no problem.
Maybe we'll catch a ride
All right,
sooner or
right
later.
on.
Cheers.
You do the triple crap.
Oh yeah.